All right, so today we're talking about polynomials. And I wanted to go ahead and give you this visual before we get started because I'm going to be using a lot of these words and I wanted you to know what they meant. So the coefficient is the number that's attached to a letter. A variable is a letter. An exponent is the little number up high, and it tells you how many times to do something. And then, of course, plus and minus, those are our operators. I'm not ever going to use the word operator, but, and then a constant is a number by itself. It's a number that does not have a letter attached to it. So our coefficients are the numbers attached to the letters, then we have our letters, and we have our constants, which are numbers without letters. When we want to simplify polynomials, the important thing here is that we can only combine like terms. A lot of people think about these as like apples and oranges. Like if you pretend the x's are apples, you have 7x's minus 3x's. Whenever you box these off, you always want to make sure you keep the sign or the operation that's in front of it. So if you think about, instead of 7x's minus 3x's, you might think of these as apples. If you had 7 apples and you minus 3, or you take away 3 apples, you are left with 4 apples. And that's true. If we do 7x minus 3x, we're left with 4 x's. So we would combine these like terms. But here's the thing. You can't say 7x's plus 5y's is 12xy's. Because we're going to pretend like these are oranges. And you can't say 7 apples plus 5 oranges is 7 apple oranges. Like there's no such thing. It doesn't exist. So when you are simplifying polynomials, you can only combine the things that are like terms. In other words, you can only combine the x's with x's and the y's with y's. So let's look, if we combine our y values here, we have 5y plus y. Well, anytime you don't see a number, in a coefficient or a number in front of the letter, you always want to put a 1 there as a placeholder. Because a lot of times you'll see students say 5y plus y equals 5y's. That is not correct. If you have 5, I don't know, let's just call them oranges. If you have 5 oranges plus another orange, that's actually 6 of those. So if you do 5y plus y, you got to make sure you put the 1 there so you know that you're doing 5 plus 1 and you are getting 6 y's. So I know I've written out a whole bunch of stuff here. Typically when I do this, I don't write this much out. Typically when I would solve this is I would box off my x's and I would combine them and I would get 4 x's. And then I would circle or make some other shape for my next letter and then I would combine them and I would get 6 y's. And since 6 is positive, we're going to put a plus sign in the middle. This is our final answer. We cannot combine those and get 10 xy's. They're not like terms, so that's all we would do is 4x plus 6y. So I know I just said a lot. Let's try to simplify it on this next one. When you deal with like terms, you're finding things that have the same letter, but they also have to have the same exponent. So if you look over here, we have a negative 3x, and then we have a positive 4x squared. Now, x is the same, but because it has that power, it's actually not a like term. But negative 3x and positive 5x, those are like terms. I can go ahead and combine those. Negative 3 plus 5 is a positive 2. And then the 4x squared, it doesn't have any other x squareds that it can combine with. So we're just going to bring it down to our answer. And I'm going to go ahead and mention that typically in math, we write our final answers from highest exponent to lowest exponent. So typically this would be 4x squared plus 2x because x squared has a higher exponent than just an x. So when you combine like terms, you're looking to make sure they have the same letter and also the same exponent. Let's try some more of these. So the first one I see is b squared. Since there's not a number there, I have to put a 1 there. So I have 1b squared, and then I'm going to look and see, are there any other b squareds? Yes, right here. Make sure you keep the sign that's in front of it. Another common mistake I see is people will say, okay, that's 1, that's 4, so it must be 5b squareds. Well, that's not true because this is a negative 4. So 1 minus 4 is actually negative 3b squared. And then I look next and I have a positive 7b. It doesn't have any like terms, so we just bring it straight down. And that would be our final answer. If we look over here, the first thing I see is 2a squared. So I'm going to look and see, are there any other a squareds? And there's not. So I'm just going to bring that down to the answer. The next thing I see is positive 5a. So I'm going to look and say, are there any other a's? And in this case, there is. There's a positive 2a. So 5a plus 2a is 7 a's. All right, we're kind of switching gears a minute here. Now it says find the degree of this polynomial. The degree is the largest exponent. So I put some examples up here. In this polynomial, the largest exponent is the power of 3. So it has a degree of 3. If you don't see an exponent, this is really important. If you don't see an exponent, there's actually a 1 there because that's 1x, right? So you would put a 1 there, so the degree would be 1. And here, the degree is 5 because that is our highest exponent. I also added this. You don't necessarily have to know this yet, but I just wanted you to see it. If the x has a degree of 1, it's linear. If it's x squared, it's quadratic. If it's x to the third, it's cubic, and then so on and so forth. So if we look at this one, we look for the highest exponent. We don't always look for the first exponent, although if it's in standard form, it will be the first exponent. But you want to make sure that you skim through and check all the exponents. In this case, 3 is our highest exponent, so our degree is 3, which means it's going to be a cubic function. All right, which polynomial is modeled by the following set of algebra tiles? Well, if you've watched my videos all year, you know I'm not a huge fan of algebra tiles, but this one is kind of straightforward. So for x squareds, we have 2 of them. So we need to look through. It does not give us x to the 4th. It just gives us 2 of those x squared tiles. So we're not going to have 2x to the 4th. That's not going to be it. That's not going to be it. Both of these are correct. So now let's look at the x's. We have 1, 2, 3 x's. So we're going to write that as 3 x's, which both of those are correct. And then here we have 1, 2, 3, 4, 5, 6 numbers. And they're red, or they're purple in this case. But typically in algebra tiles, one side will be positive, the other will be negative. So since these are a different color, we know that those are going to be negative. So this one should be our answer. And then the last thing is the in behavior. In behavior, it's asking, where are the ends of the graph going? So what I did was I took this equation and I went into Desmos and I just typed it in. Where did my Desmos calculator go? Oh man, I just had it open. What did I do with it? Oh well, I'll open it again. Okay, and so I would type this equation, y equals 2x to the third minus x, into Desmos. Y equals 2x, raise it to the third, and then minus x. So once you type it into Desmos, you're going to look at the graph. And I just took a snip of the graph. I just took a picture of it and I copied and pasted it over here. This is what Desmos told me. So now, since I'm talking about end behavior, I am going to mark where the ends go. So since this goes up forever, I'm going to put an up arrow. But I always also put an arrow pointing in whichever direction it's moving. So like, if it's over on the x side, I would point the arrow going that way. Here we have a down arrow, but we also need to add our arrow going towards the outside of the graph. So I'm going to go ahead and add those arrows in. That's going to tell me about end behavior, and then I'm going to write it. And here's how you write it. The way you write it might look really confusing, but it's not supposed to be. It just says, as x goes towards infinity, which means as you move in the positive x direction, what happens to y? Well, in this case, as we move in the positive x direction, our y is pointing up. So when we're over here in the positive x's, our y values are going up. So we would say that our y goes to positive infinity. And then the next thing you always do is you always say as x goes to or approaches negative infinity. And then you try to figure out where y is going to. So let me highlight this. This first part of end behavior is always there. It doesn't change. You always say as x goes to positive infinity, where does y go? And as x goes to negative infinity, where does y go? So really the part that you're answering on each of these is you're figuring out where y goes in each situation. And goes is kind of a not official word. The word you're supposed to use in math is approaches. But let me go ahead and look at this. So as x approaches negative infinity, that just means when you're looking on the negative side of x, so as we move this way into negative x's, which way does y go? And in this case, our y is pointing down. And down means it's approaching negative infinity. If it's pointing up, it's positive. If it's pointing down, it's negative. So this one would be your end behavior. As x approaches positive infinity, y approaches positive infinity. And as x approaches negative infinity, y approaches negative infinity. Because you have one end going up and you have one end going down. If you had both ends going up, then if you look down here, you notice that both of them approach positive infinity because they both go up. If you had both ends going down, then they would both approach negative infinity. If you had the right going down, up on the right and down on the left, then that's what we saw here. And then the opposite if it was going the other way. So if it was like this, then you would be going to positive infinity first and then negative infinity second. So really when you want to do end behavior, graph it, put it in Desmos, graph it, and then just look at where the ends are pointing. And I think that's it. Yep, good luck on this quiz.